Assalamualaikum. My name is Amzar Muzaffar brand Arjunaidi. Matrix number CF220081, and this is our project presentation. And thanks to Dr. Norhafizah Binti Salleh for guiding us to execute this project smoothly. And this is our group member, consists of 5, including me, which is Muhammad Alif Haiqal bin Paisal, CF220043, and Muhammad Hakim bin Abdul Rahim, matrix number CF220195. Next, Amyra Natasya binti Muhammad Azam, matrix number CF220227. And lastly, Muhammad Nazreensyah bin Syahril, matrix number CF220229. Okay, for introduction, the aim of the study is to explore the potential of recycled material in the creation of composite material plate. By repurposing and reimagining material that would otherwise become waste, we strive to not only elevate the pressure on natural resources, but also contribute to the circular economy, where materials are used, recycled, and granted a new life. And for the objective, to analyze method calculation for sample testing, and to distinguish data from other groups to make a comparison. And for problem statement, finding maximum strength of composite material, and observing the failure graph of plate sample. Okay, next is the choice of material. Okay, for the composite plate, we use fabric, hard plastic, and paper. And for the testing and the constructing of composite plate, we use marker, stationery, ruler, scissor, glue, and for the testing we use UTM machine, which is universal testing machine. Okay, next is for material costing. Okay, for these 3 pieces of material, we did not spend any money because we found that in the area of Pewira, which is our house, and it is easy to find. For the fabrication time, in this project, the fabrication time is broken down into the time required for material collection, design, and manufacturing of the plate structure, including layering, and the time required for the gluing process. Plate construction and layering only takes about 20 to 30 minutes, but it takes 1 to 2 days for the glue to really work well to bind all this material. The composite plate construction takes at least 3 days to build up and to withstand large load, where heat and pressure play a major role in ensuring the plate is designed to perform at its optimum. And next is for methodology. Method of project completion is from the start we discuss the choice of material, and next for material preparation. After that, construction of composite plate, including curing and testing. And after that, we collect data and analyze, including data comparison from other group, and then report preparation.
For the strength analysis calculation, there are several factors necessitate the necessity of strength analysis calculations for the stress and strain results of a composite plate. By analyzing the composite plate strain, we can guarantee that it can withstand the anticipated loads and operating conditions without failing or sustaining structural damage. This analysis helps ensure the plate's safety and dependability. Analyzing the strength of various design configurations and material combinations permits us to determine the most efficient and effective solution. And by analyzing stress and strain results, we are able to identify potential weak points or area of excessive deformation and modify the design accordingly. And for the result, the test is carried out by first securing the 2 ends of a suitably prepared and standardized test piece in a tensile test machine, and then applying a uniaxial load that is gradually increased until the point at which the piece fails. In order to ensure that the results can be reproduced and compared accurately, the test beds are standardized.
Assalamualaikum and hi, my name is Amyra Natasya Binti Azam, and I will proceed this presentation with the result of the test. So this is the tensile detail for sample number 1. The first one is width, which is 20 millimeter. The length is 200 millimeter. Thickness for 2 millimeter. Maximum load 0.24455 kilonewton, and then maximum extension for 19.40318 millimeter. Maximum point load 3142, and then the last one is maximum extension point, which is 3154. So this is the graph for result sample 1. The highest load is 0.24455 kilonewton. The next one is the calculation result for sample number 1. The normal stress is 6.11 to the power of -3, and then strain for -0.0298, which is compressive. And then Young modulus -0.205 Newton millimeter square. Cross section area is 40 millimeter square. Maximum tensile strength is 6.11 MPa. Yield strength 78.55 MPa, and then strength at failure for plastic is 0.008 MPa, and then for cloth 0.003 MPa. The next one, we proceed with result for sample number 2, and this is the detail. Width, length and thickness is the same as sample number 1, which is 20 millimeter for width, 200 millimeter for length, and then 2 millimeter for thickness. For maximum load 0.27411 kilonewton. Maximum extension 21.21306 millimeter. Maximum point load 1565, and then the last one is maximum extension point, which is 2245. And then this is the graph for result sample number 2. The maximum load is 0.27411 kilonewton. And then the next one is the result calculation for sample number 2. The normal stress is 6.065 to the power of -2 Newton millimeter square. The normal strength is 0.06, which is corresponds. And then the Young modulus, we got 0.994 Newton millimeter square. Cross section area same as sample number 1, which is 40 millimeter square. Maximum tensile strength, which is 6.85 MPa, and yield strength 39.13. The last one is strength at failure for plastic and cloth, same like the sample number 1, which is 0.008 MPa for plastic, and then 0.003 MPa for cloth. And this is the last one sample, which is sample 3, and this is the tensile detail. Width, length and thickness same as sample number 1 and sample number 2, which is width 20 millimeter, length 200 millimeter, and thickness 2 millimeter. For maximum load 0.27973 kilonewton, and then maximum extension 17.04906 millimeter. Maximum point load 1109. Maximum extension point 1572. And this is the last graph, which is graph result for sample number 3, and then the maximum load is 0.27973 kilonewton. This is the result calculation for sample number 3. The normal stress, we got 0.0699 Newton millimeter square. Normal strain -0.148, which is compressive. Young modulus for -0.472 Newton millimeter square. The cross section area is same as sample number 1 and sample number 2, which is 40 millimeter square. Maximum tensile strength, we got 6.99 MPa. Yield strength 27.73 MPa, and then strength at failure same like sample number 1 and sample number 2, which is 0.008 MPa for plastic, and then 0.003 MPa for cloth. Last but not least is the total sample result. For young modulus, average is negative 0.205 plus 0.994 plus negative 0.472 divided by 3. So the total average for young modulus is 0.106. The area, 200 millimeter times 20 millimeter, we got 4000 millimeter square. And the last one is ultimate strength, 6.11 plus 6.85 plus 6.99 divided by 4000. The total for ultimate strength is 4.986 to the power of negative 3 MPa. That's all for the calculations part, and that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim bin Abdul Rahim. My matrix card number is CF220195. I will explain about analysis and discussion. First, the data that was obtained from the universal testing machine demonstrates that there is a difference in the rates of extension in composite plates, samples made from recycled material. The strain and stress of both sample specimens were determined by first calculating the cross-sectional area, then the length, then the extension, and finally the axial loads. 3. When both the plastic and the clothes were loaded to the same extent, there was a relatively high extension in both material. 4. This can be explained by the dissimilar microcrystalline structures present in the two different samples of the material. The yield strength that can be reached in the first sample is 78.55 megapascal. The yield strength that can be reached in the second sample is 39.13 megapascal, and the yield strength that can be reached in the third sample is 27.73 megapascal. 5. As a result, it is clear that sample 1 has the highest yield strength of the three. The yield strength of sample 2 is considered to be medium, while the yield strength of sample 3 is considered to be low. The Young modulus is determined by the ingredient of the stress-strain curve, which influence the amount of material deflection that occurred under various load. The value of Young modulus in sample 1 is negative 0.205, while the value in sample 2 is 0.994, and the value in sample 3, which is the most recent sample, is negative 0.472. Lastly, therefore, the overall average Young modulus for these three samples is 0.106, and the overall average ultimate strength is 4.986 times 0 power of negative 3 megapascal. That's all. Thank you.
Assalamualaikum. My name is Muhammad Alif Haiqal bin Paisal. My matrix number is CF220903. I will present about the conclusion of our project. Okay, first, composite material needs to be more durable than individual components. Then, the strength of 3 samples of composite plates made with the same design was less than 10 GPa, falling short of the requirement for a strength of at least 10 GPa. Then, since we didn't reach to all of the requirements, we can conclude that we failed to manufacture composite material plates for this project and didn't accomplish our project objective. Then, this is as a result of various topics covered in the discussion area. Then, Finally, in order to produce composite material plates, failure factors such as glue consistency and pressure difference must be avoided. Then, apply each layer using the best adhesive possible. Then, expensive epoxy that is liquid is strongly advised. This is considerably boost the strength of the plate. The best method to construct a composite material plate is to soak the plate in epoxy rather than using glue to attach all of the layer. Then it is important to position the plate properly with the layer made of weak material on the inside and layer must make of the strong material of the exterior. Lastly, while creating the sample, use heat to guarantee strong bonding between all the layer. Okay, that's all from our group. Thank you.